In this video, we are going to solve a lot of examples on trig identities and equations. We are going to start with the simplest of examples and then we move on to more complex examples. So without wasting much time, let's get into today's lesson. So even before we start solving questions, there are some basic trig identities that we need to know, even though we are not going to prove that in today's video. So the first one is tan theta is equal to sin theta divided by cos theta. Next, we have cot theta is equal to 1 over tan theta. Now, if cot theta is equal to 1 over tan theta, then we can further simplify this by substituting tan theta in here. So this becomes 1 over sin theta over cos theta. So basically that becomes 1 over 1 times, we are going to flip this so that it becomes cos theta over sin theta, and finally we have cos theta over sin theta. Therefore, cot theta is equal to cos theta over sin theta. Cosec theta is equal to 1 over sin theta. Let's call this equation 3. And then we have sec theta is equal to 1 over cos theta. We have sin squared theta plus cos squared theta is equal to 1. Let's call this equation 5. And then we have 1 plus tan squared theta is equal to cot squared theta. And then 1 plus cot squared theta is equal to cosec square theta. So basically, these are the trig identities we need to know offhand, and these are going to help us to solve the questions that we have for today. Now let's proceed as we solve today's questions. So we have our first question here. Show that tan theta plus cot theta is equal to sec theta times cosec theta. Let's solve this question together. So we are to show that tan theta plus cot theta is equal to sec theta times cosec theta. Now we know that tan theta is equal to sin theta over cos theta, and then we know that cot theta is also equal to cos theta over sin theta. So that is cot theta, and it's equal to cos theta over sin theta. So we can't be writing this all the time, so we just write is equal to the right hand side. Now we are going to find LCM. We are going to find the LCM between cos theta and sin theta. So the LCM between the two is cos theta times sin theta. Now when you divide cos theta sin theta by cos theta, you'll be left with sin theta, and then you multiply sin theta and then sin theta, and then you have sin square theta plus cos theta sin theta divided by sin theta is equal to cos theta. So cos theta times cos theta is equal to cos square theta, and that is equal to the right hand side. Also, we know that sin square theta plus cos square theta is equal to 1. That is from equation 5. Therefore, we have 1 over cos theta sin theta is equal to the right hand side. Now we can simplify this expression as 1 over cos theta times 1 over sin theta. And we know that 1 over cos theta is equal to sec theta, and then 1 over sin theta is equal to cosec theta. Therefore, we have sec theta times cosec theta. Now, on the right hand side, we have sec theta cosec theta. So we can just write that here. Hence, we say that tan theta plus cot theta is equal to sec theta times cosec theta. Hence, the proof. Now, let's solve another question. Now to question 2. Show whether or not tan squared theta minus sin squared theta is equal to sin 4 theta times sec squared theta. So we are to show whether or not tan squared theta minus sin squared theta is equal to sin 4 theta times sec square theta. Now from the trig identities, we know that tan theta is equal to sin theta over cos theta. So tan squared theta will be equal to sin theta over cos theta all square, and this is equal to sin squared theta over cos squared theta. So we are going to input that here. So in place of tan squared theta, we have sin squared theta over cos squared theta minus sin squared theta over 1. Basically, it's the same as what we have here, and this is equal to the expression we have on the right hand side. Now let's find the LCM. The LCM between cos squared theta and 1 is cos squared theta. We divide cos squared theta by cos squared theta, and then we have 1. 1 times sin squared theta is sin squared theta minus cos squared theta divided by 1 is cos squared theta. We multiply it by sin squared theta, and then we have sin squared theta times cos squared theta. At this point, we can factor out sin squared theta at the numerator because it's common to both terms. So we have sin squared theta out, and then 1 minus cos squared theta all divided by cos squared theta equals to the expression we have on the right hand side. Now we know that sin squared theta plus cos squared theta is equal to 1. Therefore, we can say that sin squared theta is equal to, we transpose cos squared theta to the right hand side so that we have minus cos squared theta. So we are going to input this in here. So this becomes sin squared theta times sin squared theta all divided by cos squared theta. So we multiply sin squared theta, and then we have sin 4 theta over cos squared theta And this can also be written or simplified as sine 4 theta times 1 over cos square theta. And this is equal to the expression on the right hand side. So this becomes sine 4 theta times 1 over cos square theta is equal to sec square theta. So we input that here, and then we have sine 4 theta times sec square theta. And that is the same as the expression we have on the right hand side. Sine 4 theta times sec square theta. Now, since the expression on the left hand side is equal to what we have on the right hand side, we say that it is true that tan square theta minus sine square theta is equal to sine 4 theta times sec square theta. Now let's solve this question together. Prove that 1 plus cot theta divided by 1 plus tan theta is equal to cot theta. So we have 1 plus cot theta divided by 1 plus tan theta equals cot theta. Now from the trig identities, we know that cot theta is equal to cos theta over sin theta, and then tan theta is equal to sin theta over cos theta. Therefore, 1 plus cot theta becomes 1 plus cos theta over sin theta, and then we have this all over 1 plus tan theta also becomes sin theta over cos theta, and this is equal to cot theta. Now let's proceed. So considering the numerator, the LCM between 1 and sin theta is sin theta. Sin theta divided by 1 is sin theta, times 1 we still have sin theta, plus sin theta divided by sin theta is 1, times cos theta we have cos theta, and then we have divided by, this time to the denominator, the LCM is cos theta. Cos theta divided by 1 is cos theta, times 1 we still have cos theta, plus cos theta divided by cos theta is 1, times sin theta we have sin theta, and this is equal to cot theta. At this point, we are going to flip the denominator so that we have sin theta plus cos theta divided by sin theta times cos theta over cos theta plus sin theta. Let's continue the solution here. So we have cos theta plus sin theta, cancelling out sin theta plus cos theta. We know addition is commutative, so a plus b is equal to b plus a. So if that happens, then we have cos theta divided by sin theta equals cot theta. And then we all know that cos theta divided by sin theta is equal to cot theta. That is what we did here. So we say this is equal to cot theta, and since cot theta is equal to cot theta, we say that hence 1 plus cot theta divided by 1 plus tan theta is equal to cot theta. Now to question 4. Show that cos squared theta minus sin squared theta is equal to 1 minus 2 sin squared theta. Show that cos squared theta minus sin squared theta is equal to 1 minus 2 sin squared theta. Now from the trig identities, we know that sin squared theta plus cos squared theta is equal to 1. So we can say that cos squared theta is equal to 1 minus sin squared theta. That is, we transpose sin squared theta to the right hand side. So let's input cos squared theta in here. So this becomes 1 minus sin squared theta minus sin squared theta equals 1 minus 2 sin squared theta. And then finally, we have 1 minus negative sin squared theta minus sin squared theta is negative 2 sin squared theta. So since the expression on the left hand side is equal to the expression on the right hand side, we say that hence cos squared theta minus sin squared theta is equal to 1 minus 2 sin square theta. Now to the very last question. Question 5. Prove that the square root of 1 minus sin x over 1 plus sin x is equal to sec x minus tan x. So on the left hand side, we have the expression the square root of 1 minus sin x over 1 plus sin x, and that is equal to sec x minus tan x. Now let's focus on the expression on the left hand side. Now if you have an expression like 1 minus a over 1 plus a, you can choose to multiply both the numerator and the denominator by 1 minus a, 1 minus a, and it's obviously the same thing. If you cancel the two, you still have what you started with at the beginning. So that is exactly what we are going to do here. So we have the square root of 1 minus sin x divided by 1 plus sin x times 1 minus sin x over 1 minus sin x, and that is equal to the expression on the right hand side. Now at this point, let's try to multiply across. So we have the square root of 1 minus sin x times 1 minus sin x becomes 1 minus sin x all square. Now for the denominator, we are going to multiply 1 times 1, we have 1. 1 times negative sin x becomes negative sin x. Sin x times 1 becomes plus sin x. And then sin x times negative sin x becomes negative sin square x. So we simplify this, and then we have 1 minus negative sin x cancels out sin x. So we have 1 minus sin square x. 1 minus sine square x, and that is equal to the expression on the right hand side. Now from trig identities, we know that sine square x plus cos square x equals 1. Therefore, we can say that cos square x is equal to 1 minus sine square x. So 1 minus sine square x becomes cos square x. Therefore, we have 1 minus sine x all square divided by cos square x. Now cos square x is the same as cos x all square. So instead of writing cos square x, we are going to write cos x all square. Now from the laws of indices, a square over b square can be written as a over b all square. So we are going to apply that here. So 1 minus sine x all square divided by cos x all square can be simplified as 1 minus sine x divided by cos x all square, and this is equal to RHS. Now the square cancels the square roots, and then we are left with 1 minus sine x over cos x. Now 1 minus sine x over cos x, we can simplify this as 1 over cos x minus sine x over cos x. 1 over cos x is sec x. Here we have 1 over cos theta equals sec theta. So 1 over cos x is sec x. So this becomes sec x minus sine x over cos x is tan x. So that is the same as the expression we have on the right hand side. That is sec x minus tan x. Now since the expression on the left hand side is equal to what we have on the right hand side, we say that hence the square root of 1 minus sine x over 1 plus sine x is equal to sec x minus tan x. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.